Okay, so just click on Structure tab, and then here we have CYPE 3D. Click on CYPE 3D. And before starting the training, again, I believe that you are using the software, so which means that you have installed the, sorry, you installed the software, and so I expect you to practice with me. Okay, so that's why if you feel that I'm going fast, please let me know. I can slow down my speed. And if you have any question, you can stop me and you can ask your questions. Okay, so for just starting, with a new project after opening the CYPE 3D. So here, this is the first page that you see after double clicking or, just run the CYPE 3D. So then here we have the, let's say files, and then you have examples, you have file manager, and then you have recent files, and also here you have the help. Okay, so the most important thing here maybe is file manager. If you go to click on file manager, so here you can see, for example, for me here, I have actually plenty of projects, whether actually, I did it as training or demo, or maybe, I participated in some real projects. And that's why all the projects will be listed under file manager. Okay, so that's why here you can see it. And another, let's say, thing that you want to know is about the compress and decompress option, and also about the share button that you have here. Okay. In recent version or latest version that you have, which is version 2026.b, thankfully, we have the same manner whenever you want to open up a file. Let's say, for example, in StatPro, you can share the STD file format, right? Let's say from GAO to HAO. And then, so HAO once receive the STD file, so he can actually not just double click on the STD file, and then so StatPro pop up, right? So here in the latest version, we have the same thing. Okay, so just you need to, for example, save your model or save as any name that you want, and then you can share it with your colleagues or any other party, and they can double click on that. But sometimes the model get let's say a big size. Okay, so that's why you need to compress the file. So that's why here you have the compress option. Okay, and so once you click on compress, as you can see here, you are getting the .cyp file format. Okay, so this is the file format for let's say sharing the CYPE models. It doesn't matter about the CYPE 3D or CYPECAD or any other CYPE solutions. Okay, so once you click on compress or share, at the end of the day, so you will get the .cyp file format. So once you get this format, the .cyp, so you cannot double click on the file to open it up. So once you have the .cyp file format, so you need to open or run the software, for example, here, the CYPE 3D. And then, so already you save the model in any local folder. And then, so for opening it, so you need to click on decompress. Okay, so if I click on decompress, and then, so from here, if I go, for example, to desktop, so here I don't have actually, any file, but you can see here, so you can open up the .cyp file format. But the easiest way right now, just like a StatPro, so you can, just save the model or save as any name, and you can share with, your colleagues in the ED3 format, okay? And then, so you will just double click on the file and you can open it up. That's it. Okay, but as I told you, sometimes your file is heavy, okay, is big in size, so that's why you can come to compress or you can come to share in this way, so you can decrease the size of the file and you can share it easier. Okay, so let me just close this. And another part is about the help, about the, let's say, user manual, calculation, or example. So if you want to read it by yourself, so always you can click on these options. For example, if I go to calculations, just click on that, and then here you have the document. And if I click on calculations, so here you will see how does the software calculate the, for example, the bars or beams in StatPro. Here we call it bar, okay? Or foundation, or maybe, the other type of members that we have, like castellated beam or composite beams, okay? So here you can see that, for example, if you go to limited state, so here you can read the information, okay? So this is the thing that you may need to go through them, by yourself. Let's get started by clicking on new. And then here, so I will say, you can name it as you wish. Okay, so here I will say Megatech, if I'm writing correctly. So let me see.
EK.
Yeah, Megatech. Okay.
EK.
Megatech.
Yep.
Okay, and then today is 2026 0107. Okay, so this is for myself. You can name it as you wish. Okay, and then accept. So since you want to start modeling from scratch, so here you have the empty project. Okay, sometimes you are working, for example, with the StatPro or maybe, SAP 2000 or maybe ETABS. Okay, those software, especially, SAP 2000 and ETABS, they can provide or generate the IFC file format. The StatPro cannot directly generate the IFC file format. So that's why you have kind of limitation in the StatPro to generate the IFC file format, okay? But let's say still there is a way to generate the IFC file format, through the Bentley solutions. But assume that you are working with other consultants or other parties that they are working with ETABS or SAP 2000. So quickly you can ask them to generate the IFC file format, and then you can come here and you can just bring the IFC file format quickly to CYPE 3D. Okay, so you have all the sections and material, everything. By the way, if you go to my YouTube channel, okay, so you can subscribe to my YouTube channel, and then from here, for example, you can see how you can export, for example, SAP 2000 model to CYPE 3D. Or if you go to the videos or maybe the playlist, so here if you go to the playlist, and then so just you need to look at the CYPE 3D. Okay, if I go to the CYPE 3D, and then so if I come down, let's say about the latest videos, so here you can see how to export 3D DXF from StatPro to CYPE 3D, or how to export 3D DXF from CYPE 3D to StatPro. Okay, so here you can just get this kind of tutorials. And by the way, I am preparing the tutorial based on the client request. Okay, so that's why you are getting kind of practical tutorials. Okay, so this is the
Dr. Khalid, can you
let's say
share the
difference
YouTube?
between, yeah,
Can you share the
my YouTube
YouTube link
channel and
into
others.
the group?
Come again, please.
Can you share the YouTube link into the WhatsApp group?
In the WhatsApp group, just go to YouTube, and then search for PASOFAL. That's it.
PASOFAL.
Yeah, PASOFAL. Okay.
Okay.
Okay. Okay, so let's go back to empty project, and then so accept. So we call this window as general setting window. And as you can see here, the first one is codes. Okay, so always if you want to change the code, so you can click on this option. Okay, just click on this, and then here, so you have the concrete material, cold form steel, ruled steel, timber, and aluminum. Okay, so let's say in this example, so I will change everything to generic Eurocode. So I will go to Eurocode 2 for concrete. For cold form, again, I will go to Eurocode 3 and 4. For ruled steel also, generic Eurocode 3 and 4. Most probably for you, by default is EC3 and EC4, okay? So you don't need to change it. But since I use CYPE 3D daily, for different purposes, so that's why you can see I was using, a American code. And then for timber, I'm not caring about the timber because, here in this training, we are not going to model or design any timber. And also for aluminum, so we have the EC9 only. So I also set the concrete to EC2 because once you are using the Eurocode or generic Eurocode, so you can design the connections automatically, okay, standard type connections. But for non-standard type connections, so you can use the CYPE connect. So later we have we will have another session, for CYPE Connect, and we will show you how to use the CYPE Connect for designing the simple to complex connections. And most probably, I will go to model purlins using cold form steels. So that's why, again, here I set it as generic EC3 and EC4. And definitely, the majority of the members that I'm going to model in this tutorial or training is ruled steel. Okay, so that's why here I set it to EC3 and 4. And then accept. So as soon as you accepted this, the software will ask you about the categories of live load. This is according to EC1. Okay, so the actions on structures. Okay, you can click on this, and then here you can select. For example, here we are going to create a warehouse, let's say. Okay, and then so I can say that, okay, so my live load category is warehouse. But sometimes maybe you have also offices as well, okay, inside the warehouse. Maybe inside the warehouse you have the meeting areas as well. So you can, just add it as you want, okay? And then so here, for example, for this one, I will select the warehouse, accept, and then so I have the office room in warehouse. So here I will say offices and then accept. As you can see here, so you can add as much as you want, okay, based on the application of the areas that you have. Okay, so here I will, for now, I will just delete this one. Okay, so usually what is my practice? So I'm not really caring about, what kind of live load I have, because usually, for live load, simply I can go to EC1 and then, based on the category or application of the areas that I have, so I can, just apply the magnitude of live load. Okay, so that's why here, for example, I'm going to let's say generate or model a warehouse, but I will say that, okay, so I have the domestic and household category. Okay, and then accept. And then accept. Okay, this one is for timber. Again, I'm not caring about it. Accept. Okay, so now you can see already all the codes. Previously was American code, but right now, so I changed them to EC2 and 3. Okay, let's go to another section. So here I have the material grade of steel, cold form, timber, aluminum, and then concrete. Okay, so let's set this ruled steel for S275. Cold form also I will go for S275. This is up to you. Okay, so here you have different type of materials, and if you want to customize it for yourself, so here you have the steel user library. Okay, click on that, and then here, so you can create your own material library for ruled steel and for cold form steel. Okay, and again, I'm not caring about the timber and aluminum in this example. And then for concrete, so maybe I can say C30/37 for designing the base plate. Okay, another material grade is related to reinforced concrete, as you can see here. And if you want to be more specific, because this one is a generic one or general one, okay? But if you want to be more specific for the columns grade, and then for beams and floor slab grades, and for foundation elements grades, okay? So here you can, change them. But I'm going to accept, let's say, the generic one as C30/37. Okay, so another let's say option, especially once you have the seismic requirement. So here you have the with dynamic earthquake loading. If you click on that, so here you have the numerous seismic codes according to different countries. So you have the American code, you have the Euro code for EC8, you have the Malaysia annex to EC8. I'm not sure if I'm not mistaken, Megatech has offices, in Philippines. So maybe, you can use the Philippine earthquake. Okay. And Thailand also, I remember, during my presentation to you, I was looking at your website, and if I'm not mistaken again, so you have the office in Thailand as well. Okay, so you have the seismic code according to Thailand requirement as well. Okay, so let me go back to EC8, or maybe you can use the Malaysia annex to EC8. By the way, Gao,
Yeah.
let's say how often you use seismic codes, or let's say, the seismic is a requirement for your projects.
If client require a calculation for earthquake, then we will have to provide.
Come again, please.
If the client requires us to do an earthquake calculation, then we will have to
Okay.
provide.
Okay. So for now, I I would like actually now to skip this one, but no worries. So once you have the requirement, so just put some comments in the group, and then so we will have maybe for let's say 15 minutes or 30 minutes. So I will cover the seismic as well. Okay, but for now I will just skip it.
Sure.
Okay. So another option is fire resistance. Again, I'm not sure if you have this requirement as well, but you have actually the fire resistant for steel. So you can say that do not consider fire situation, or you can go for check fire situation according actually to the resistance or our resistance. Okay, so you can go for 15 minutes up to 240 minutes. Okay, which is 4 hours. And then here you have different kind of protective coating. Okay, so you can select any of them, and then so you can just see the specification of those protective coating. Okay, and or maybe you can go to calculate the critical temperature in a fire situation, which is actually based on the critical um, fire resistance of the member. Okay, so again in this case, let me just select the first one. Do not consider the fire situation, or maybe I can cancel it. And in terms of the limited state or generating the ULS and SLS, so you can always, just, skip this one, because the software automatically, based on the selected code, generate the ULS and SLS combinations. Okay. And then here you have the additional load cases, or let's say load types. Okay. If you click on that, so as you can see, you have the self-weight, dead load, live load, temperature, shrinkage, wind, earthquake, snow, soil pressure, or accidental, or any other type of load if you have. And one significant difference between StatPro and CYPE is self-weight. Okay, so you don't need to apply the self-weight manually in CYPE 3D like a StatPro. Okay, so you don't need to do that,
Can we
because the
not
self-weight,
can we not change the value for the self weight?
you can apply, let's say, as a dead load, and you can combine it with self-weight.
Ah, okay, I see.
Okay, is all about, because always self-weight will be considered as dead load, right? And
Yeah,
always, it
because
comes, yeah.
in some cases where our steel structure we require to calculate the self weight for the connections too. So we would prefer if we can include the self weight of the connections into this steel structure.
Yeah, the self weight, yeah, I will show you. You can also do that, okay? Or quickly you can come to, for example, dead load here, okay? And then here, so I will say that, okay, so just you see this is small icon that you have. So this is the option to let's say add or edit the type of loads, okay? For example, here I want to create one additional self weight, okay? So here I will go to dead load. I know that, by default, the 100% of member self weight will be calculated, but you want to have your own self weight, right? So
Yes.
you can let's say deactivate this one. I will show you how. Okay, but here I will, just like a stat pro, so you can just apply it manually. For example, I will go to the dead load and click on this small icon that you have here. Okay, and then here you have the new additional load case. If I click on this, so here I will say SW. Okay, so represent for self weight. And okay, so here I will accept. You see here I have the self weight. And then the another type of load that I have, so I want to create as general dead load. Okay, so here, and then here I will say DL, dead load. Okay, and then accept. So now here you have a very nice option. So you have the choice to combine this self weight with dead load, or ignore to, let's say, combine this self weight with dead load. Okay, you see here also you can see that once you have this green check symbol, so you have the combinable, and once you click on this, so it said not combinable. Okay, so this is something unique that you have it, and you have control over these combinations. Okay, but let's say here we want to have the self weight to be combined with dead load. Okay, so now I created self weight and dead load, but later I will exclude self weight to the members or shell or whatever elements I am creating. Okay, let's say accept. And also I'm going to apply one live load or create one live load. Again, click on this small icon and then new additional load case. And then here, so I will say live load. Okay, and then accept. And again, accept. Okay, another option. So we can go for wind load. If you, again, just like this case, we are starting from scratch, right? So in CYPE3D itself, so you don't have the automated wind load generation, okay? So that's why the portal frame generator comes to the picture as a part of CYPE3D solution, okay? So maybe later I will show you how you can use the portal frame generator as part of CYPE3D. Okay, but for now, let me just continue with wind load. Okay, so I can apply it manually, but I will show you how, by using a feature, we call it load panel. The load panel option automatically decompose or convert the pressure loads to member loads. Okay, let me just create two types of wind load, let's say in X direction and Y direction. Okay, so here I will say that W, let's say as a wind, plus X, okay, and then accept. And I will go to new additional load case again. So here I will say W plus Y. Okay, so Y I'm applying only two wind load cases because I'm going to have the symmetrical geometry of the portal frame, okay? It means that, let's say, the positive X can be equal to negative X and positive Y equals to negative Y, okay? And look at here, you see the software is smart enough to understand once you are applying the wind load in X and Y direction by default, the software doesn't go to combine these two loads because again, the logic is there, yeah? So in reality, so you don't have the effect of wind load in X and Y direction. And usually, we don't do that. Okay, but again, if you want to combine the wind in positive X or negative Y or positive Y or any direction that you have, so you want to combine together, so you can, just activate this option. All up to you as a designer. Okay, but the flexibility is here. Okay, so here I created two wind load cases in positive X and Y, and again, accept. That's it. So let's say, for creating the load types, I'm happy with self-weight and dead load and live load and wind load. That's it, accept. Okay, so the software is able to design the concrete members as well. Okay, so if you have the column, if you have the concrete column, concrete beam, so you can always go to the column and beam options to set the reinforcement rules for yourself, or maybe you want to customize the reinforcement table. Okay, so for example, if I click on columns, you see here I have the reinforcement table, and if I click on this option, you see here you have actually the reinforcement table, and you have some kind of settings here. You can just adjust it according to your company requirement for rectangular columns or circular columns. And then here you have the stirrup arrangement, and then here you have actually with uh, let's say 2 legs stirrup, 3 legs stirrups. Okay, how do you want to connect to each other? So you have different kind of cross it options. Okay, and once you did it, always you can save as default settings. Okay, so we call it one-time settings. So it doesn't mean that every time you are running CYPE3D, so you need to come to this settings. And another point that I need to bring it to your attention is about changing these settings. So I recommend you not changing these options unless otherwise after running the analysis and design. So if you are getting some kind of errors or failure for beams or columns, and you need to work with the reinforcement, so you can come back here under general settings window, and then come to column for reinforcement rules, and you can change or apply some modifications here. Otherwise, just leave everything as default, because everything just set according to selected codes. Okay, so again, I'm not going to change anything here. This is exactly, same for the beams. Okay, you can go to the options, and then as you can see here, you have the beam reinforcement table, reinforcement arrangement, forces, design and code checks, steel beams, drawings. Okay, so you have all the options. And similarly for foundations, okay, if you go there, you have actually rules for pad footings, pile caps, strap beams, tie beams, okay, and even code check for cracking. But the last one is the joints or connections. Okay, if you click on that again here, so you have the material. Assume that for standard type connections that we have, even in this example. So I'm gonna go to create some standard type connections. So that's why I know that from now I know that I'm going to have the end plate or fin plate or cleats. Okay, so that's why for those end plate materials, so I'm gonna select S275. Okay, and for the bolts, I'm going to select, let's say, grade 8.8. Okay, and for concrete, so I will select the C30/37. Okay, and then accept. And if you go to the options, so here you have different type of non-pre-stressed bolts. Okay, so here you have it bolt steel class, and then available diameters, and maybe you have or let's say you're supposed to use some uncommon diameters as well, so you can just select them. And similarly, you have the pre-stressed bolts. So the difference between pre-stressed and non-pre-stressed bolt is about the bolt series, and also here you have the friction surface classes. Okay, so based on your requirement, you can select and go ahead with your design. And for the stiffeners, again here, so you can, just say that at the hunch ends, you want to provide the stiffeners, in column beam joints, or maybe, in rigid joints only. And then, the type of the stiffeners could be a stiffener without trims, or maybe, with trims as well. And also for the base plate, so here you can, just read the parameters and you can set it for yourself. Again, here you have the save as default settings. Okay, so always once you come up with the requirement that accordance to your company requirement, so you can save it as default settings. So next time opening CYPE 3D, so you have the previous settings. Again, I'm not going to change anything for now. If you have the concrete beam under environment, so you can click on this X0, let's say, and here you can set the exposure class to check the crack width of the beams. Okay, so by default again is no risk of corrosion of attack, corrosion induced by carbonation, induced by chlorides from seawater, and then freeze and thaw attack, or maybe chemical attack. And then so by selecting any of these options, so here you have different designations, and then again here you can read the information. Okay, and you can set the maximum crack width option. Again, I'm not going actually to change anything here because we don't have any concrete members for this tutorial. And in terms of foundation design, so if you want to consider the let's say a sliding and overturning moment, okay, so you can activate this option, verify footing sliding, and then you can get the information from the geotech engineer, like coherence or adherence of the soil capacity, and then friction angle of the soil. And from here also you have the options to key in the allowable soil bearing pressure. Okay, so here you have the persistent situation, seismic, and accidental situation. If I want to put it, in a simple way, so the first one is the minimum and maximum allowable soil bearing pressure. Okay, minimum and maximum. Okay, so that's why here again you can get this information from the geotech engineer, or you can go to this small icon that you have here, and you can select from the standard value according to different soil characteristic that you have, like gravel, dense sand, medium dense sand, and so on and so forth. Okay, so once you want to select any of them, for example, if I go to let's say dense sand, okay, so I can click on this and then accept. If I click on that, do you wish to assign the selected value dense sand? Yes. Okay, and as you can see here, the value will be assigned to minimum and maximum allowable soil bearing pressure. In again recent versions of CYPE, so we have the option to design the piles as well. But for piles, usually we train the let's say users in advanced training level. Okay, but for now, so the main purpose is to make you familiarize with the interface of the software and with the general settings. Okay, so that's why I'm not going to explain about the piles and pile design for now. Okay, so once you adjust these parameters, so here you have the finish option. Okay, just click on finish. And then, so here, this is the summarize of the, let's say, limited state. For example, we are using the EC2 for concrete, and then, EC2 for foundation concrete, and then, for cold form and ruled steel, we are using EC3 and 4. Okay, and then here you have the ULS, for snow level. If you don't have a snow, okay, so don't worry about this, won't be considered. And that's it. Okay, so this is, just summarize about the codes and then accept. And here you have the main interface of the software. For any reason, if you want to go back to the general setting window, so always here under project, so here you have the general data, click on this, and then so you can change the parameters as you wish. Okay, so let me just close this. Do you have any questions so far?
No.
Okay, so let's go to the interface of the software. As you can see, so we have the ribbon base. Okay, so here I have the project, and then so you can go to the geometry and then properties, loads, joints, analysis, reinforcement for, let's say, reinforced concrete members. And then here you have the window, so you can create different windows from different angles. Okay, for example, side view, front view, top view, bottom view. Okay, you can create it, and all these views, will be saved here. Right now, only we have the 3D. Okay, let me just go back to the project. Okay, so maybe for now, we don't need to set anything. So I will go to the geometry. And then so let's start the geometry of our structure. The thing that I have intended, for this training. So I want to go for something like this. Let's say here, sorry, let me just use this one. Okay. So here I want to use, let's say, a portal frame, something like this. Okay, and then so I will go in this direction, and so I will go for a few base. Okay, and then so here I will say that, for example, here I will go for 5 meter. Okay, so let's say uh, for this one, and then for, let's say, from here to here, I will go for, let's say, 12 meter. And let's say from here to here. Okay, so I will go for 1.2 meter, let's say. And for each bay, so I will go for, let's say, 8 meter. Okay, so let's create this, and how we can use the features that we have here. Okay, as you can see under geometry, you have the nodes, you have the bars, and also you have the shells. And also you have the tools in terms of, copying the members or maybe rotating them, move them, okay, search for them. Maybe, you want to change the name or reference of the members or shell or whatever we have. Okay, so it means that here under geometry, we have all the tools, to create and finish up our geometry. And also here you have the options to import the 2D or 3D DXF or DWG as well. Okay, so let me just go to bar. Okay, so quickly I can go to the bar. So once I click on this, you see in this, let's say, in this area, I have the bar by default IPE80. Okay, so I can from very beginning change the sections. For example, if you click on this IPE80 here, okay, you see you will go to let's say section libraries. But let me just close this and first, come up with the geometry of the structure, and then so I will assign a proper sections to each members. Okay, so here you see I have actually now 3 lines. Okay, these 3 lines, we call it reference lines. And if you look at the global coordinate system, which is here, okay, so here you have the X, Y, and Z direction. So that's why here you have the X direction. So this is the X direction, this is the Y direction, okay, and this one is the Z direction. Again, this one is not a grid line. This is, we call it reference line, okay. So I will, you will see actually now what is the purpose of this reference line. So for now, let me just clear everything. So already we know that, about the, let's say, dimensions of our structure. So once the bar is selected, I will go to the option. As you can see, the software again is smart enough to understand the intersect of these 3 reference lines. Okay, just click there. Okay, so once you click, you can, just move your cursor anywhere that you want. And as you can see here, the software, just like AutoCAD, shows us the length of the member and also, the angle of the member. Okay, but the thing is that, we want to go vertically. So that's why here, I'm not caring, how much I'm going far from this node, okay, or intersect of these 3 lines. So the only thing that is important for me is attaching to Z reference line, okay, or vertical reference line. Okay, so right now, for example, I'm going 3, and just you need to click, just simple click. Okay, the software always will ask you, okay, so how much is the length? So we said that 5 meter, right? Just say 5, and then, yeah, press enter. That's it. Okay, so here I have it. And as you can see here, so just by having, this member, so right now you have 2 nodes, okay? So you have 1 node here and you have another node here. As soon as you have this node, let's say, the top node, you have the corresponding reference lines to these nodes, okay? And this makes the life easy for us, okay? So it means that I can, go to this direction. Remember, we said that we need actually, 12 meter, okay? The overall span. But purposely, I'm going to 35. You see here, 35. But I know that it should be 12. Okay? Don't worry about this. Just click. Okay? And again, so the software will ask you, how much is the distance or length? Okay? So we will say 12. And again, press enter. Okay? So that's it here. Now, again, I have the corresponding reference lines to this node. Okay? So this is the reference line and this is the reference line. Okay, so I can come down, and again here I have the intersect of this reference line, which is corresponding to this node, and I have this reference line, which is corresponding to this node. Okay, and then click here. That's it. Okay, so now you can press escape to exit the command. So are you practicing with me, and your team also practicing with me
Yeah,
as well?
yeah.
Yeah,
Uh,
yeah, we're agree.
So all good, yeah? So I'm not going fast.
Yeah, yeah.
Okay, good. Okay, so now we need to create the apex location, right? So here we need to create, something like this, and then so we are thinking about here, right? So we said that 1.2. So that's why I can, come to the node, as you can see here, and I can create a new node. Okay, so just click on the node, and you see here, once I'm, just touching the any member or any reference lines, everywhere the software shows me, the measuring tool, okay, corresponding to closer or nearer nodes. For example, here it shows me 3.8 corresponding to this closer node. If I come to this one, okay, so it shows me 3.2 corresponding to left node. Okay, but I have also the options, to go to, let me just cancel this. So here you can also press shift. Okay, you can hold shift on your computer keyboard and also hold the mouse wheel. Okay, so you can rotate your model just like AutoCAD. Again, just like AutoCAD. Okay, shift and mouse wheel. You can rotate it. Okay, now you see here, I have actually now the object snap, and the software also shows me the mid of this member. If you want to see the object snap, is here. You see this small icon that you have here. This is the object snap. Okay, so just click on this, and then here, so I by default actually this is activated. Okay, endpoint, midpoint, perpendicular, nearest, and also intersection. Okay, close this. Okay, so I know that the apex location exactly at the mid of this 12 meter. So just click there. That's it. So now you see that after having the node, the color of the member turned to bold black color. What does it mean? Okay, in this case, if you just click on this section, if you click on the section, and you see, if you come to this member, you see this member still is considering as one single member. Okay, so this member is considering as single member. However, I have a node here. This is again, another difference between CYPE3D and StatPro. So in StatPro, we have the analytical modeling approach. In CYPE, we have both analytical modeling approach and physical modeling approach. So right now here, you have the physical model, okay? Or let's say real model in reality. So it doesn't matter if I have a beam here, but this member could be a single member without breaking them down. Okay, so then please pay attention once you have the let's say bold black color or highlighted black color like this. It means that the member has a node, or let's say internal node, but still the member will be considered as a single member. Okay, so let's go back to node and then go to the move option. Okay, click on move, and you can, by the way, always the software actually gives you the instruction for next step. Okay, so here it says that after clicking on the move, the software says that select an element. Okay, so we need to select this node. Okay, you see here I select the node, and then so if you look at the instruction again, select the new position of the element. Okay, you see here I have the corresponding reference line to this node. Remember we said that whenever or wherever we have the node, so always you have the corresponding reference lines. Okay, so you see here I have the corresponding reference lines. That's why I'm saying this reference line makes the life easy or modeling easy for us. Okay, so again, I'm not caring how much I'm going far from this node. Right now is about 2.6, but I want to go for 1.2. No worries, again, just click. Okay, again, the software will ask you. So 1.2 meter. Okay, and again, enter. Okay, so right now you have this let's say apex location, and again the let's say the color of this member turned to normal color. Let me see some of our friends
Dr.
already.
Khalid,
Yeah, yeah, please.
how do I adjust the text size of my member?
Okay, for text size, just go here. You see this one? This is the text size. But if you
Oh,
want to, yeah, if you want to, let's say hide or display the text or local access, okay, so here you have the options. You see, this is the options.
okay, I understand.
Okay, so usually I deactivate this local access. Okay, so here I deactivate local access, and most of the time I don't want to see the display text on the elements. Okay, so now, okay, we have actually now this frames. Okay, I have two columns and two rafters, and you see just by adding the nodes, I have the reference lines. So you don't need to do anything. So just I want to show you something. Let's say here, for example, I have the location of the purlins. Okay, I have another purlin here, another purlin here, another purlin here, and again another purlin here. You see how many reference lines are being generated. It is really tedious, right? So that's why we don't need the this reference lines always to see. Let me just undo the procedure. You see here you have the undo option. Okay, I'm doing undo procedure. But let me also tell you something. So you can go to this small earth icon here. Okay, just click on that. Okay, and then here you have the undo redo option. Okay, click on this undo redo option and set this maximum number of actions to 20. By default is 5. Okay, so change it to 20. Just give yourself, more chance for more steps. You did some kind of mistakes. Okay, at least 20 steps you can go back, 20 steps you can go forward. Okay, and then accept. Okay, so we said that we don't want to see the reference lines, okay, anymore. I can go to planes. You see here, I have the planes, this option, okay, and then come down, and here you have the references. Okay, just click on this. Yeah, any question?
No, no.
And then, yeah, and then, okay, so just uncheck reference lines, okay, and then accept. Okay, or again, if I go back to the planes, go back to references. Sometimes maybe you don't want to see the reference lines, in the X and or let's say, some specific axis. Excuse me? Okay, so for example, here I want to copy my let's say, frame in X direction. You see here, this is the X direction. Okay, so that's why I can activate the X direction only. Okay, I don't want to see the reference line in Y or Z direction. Okay, and then so I will say accept. Okay, you see here only in this direction. So now for copying the members, so here I can go to the copy option. You see here you have the copy option. This is the simple copy, okay? And again, look at the instruction. So always the software will give you the instruction. It says that select a group of elements. Okay, so here I will select everything. By the way, the selection mode is like AutoCAD again, okay? So if you come from left to right, whatever is touching the selection window will be selected, okay? If I come from left to right, so whatever is completely inside the selection window will be selected, exactly like AutoCAD, okay? So let's say from here, so I will select everything, but the instruction is still the same. So then what's happening here? So in CYPE solutions, doesn't matter CYPE 3D or CYPE CAD, you need to use right click a lot, okay? Right click to me, let's say, as a person that I'm working with CYPE, for about 8-9 years, is like a confirmation. Okay, so for example, here the software says that select a group of elements. Okay, I selected. So then I need to confirm and I need to let the software know that already I selected the elements. So what should I do? I would say right click. Okay, just confirm by right click. And then, so once I do right click, you see the instruction will be updated. It says that insert the first point. Okay, so I can select this point, I can select this point, this point, this point, or this point, because for any of these points, I have the reference line and I want to copy in the X direction. Doesn't matter, you can select any of these points. Okay, so let's say, for example, I will select the apex node. Okay, so this one, and then so I will go in this direction. It says that you want to go for 8 meter, okay? So again, doesn't matter how much, or let's say how far you are going, from this node. Just click. Again, the software will ask you the distance. We will say 8 and then enter. Okay, you can continue like this. Okay, again, right now, click, and again, 8, enter. Okay, so you can go ahead. 8, enter. Okay, so let me just escape. This is the normal way. Okay, so you can, just copy like this. But also we have a faster way to copy the elements. So let's say again, undo the procedure instead of clicking on undo option. So you can also use Control Z. Okay, Control Z. 1, 2, 3. Okay, so I have, let's say, 1 frame only. Another option that we have here is generate planes. Okay, you see, once I click on this option, the first one under generate and then planes, if you look at the instruction, the software says that select the 2 orthogonal reference lines that will define the plane on which you wish to carry out the generation. In a simple way, so the software says that you need to select 2 reference lines. Let's say I have actually no, if I have this reference line and this reference line, which is in the Y and Z direction, okay? And then this will be the perpendicular plane to the direction of the copy that I want to do it. Okay, so that's why I need to activate the reference line in the in the Y and Z direction. I will go to planes again here and then references. So this time I will say Y and Z and then accept. You see here, I have like this. Now I can go back to generate planes. Again, if you look at the instructions, select 2 orthogonal reference lines that will define the plane on which you wish to carry out the generation or copy. So I will select this reference line and this reference line. Doesn't matter. You can select also this reference line. Okay, so I will select the middle one, this one. And quickly, again, you have the new window. So the number of copy or number of planes, we will say, for example, 6 copy we need. And then separation between the planes. So we said 8 meter, right? And then accept. Okay, so here you have the 8 frames. Sorry, we have the 6 and with the original one, 7 frames. But any of them, 8 meters. Okay, if you want to measure the distance, again, under planes, here you have the dimensions. Okay, if you click on dimensions, you see right now you have in this form, but if you want to, just see it like this, okay, you can click on this small square, change the appearance of the toolbar, and maybe you can pin it. Okay, so if you want, you can pin this and you can see it. Okay, so if I go to first of all, if I go to delete, okay, so I can see that some of the let's say dimensions generated automatically. So I want to remove everything, so you can select everything and the dimensions will be selected. And again, so if you look at the instruction, so here you see, look at the instruction and it says that select a group of elements. Okay, already I select this, let's say dimensions. You see here, I select this dimensions. What should I do in the next step? So you need to confirm it, isn't it? And then do right click. That's it. Okay, so here we have 2 options, add and show. Okay, so this is something different. It's not like, for example, a StatPro or eTabs or SAP 2000. If you want to add the measures or let's say, dimensions, you need to go to add. So here you need to go to show. Okay, so if I click on show, and then, for example, I will select on this node and this node. By the way, if you want to increase the node size, also you can, increase it from here, dimensions of the nodes. Okay, so let me just go for 66. Okay, so I can just see it better. Okay, so I will click on this node, and as you can see here, so the software measure in 3 different directions. Okay, so I will go to this direction. So this is 8. If I want to see it better again, so I can go to the text size, and then so I will go for example 400. Okay, so now is much better in terms of visibility. 8, 8, 8, 8, and 8. Okay, and also I can go from here and here. So the overall is 48. So what is the meaning of add option? Okay, so right now we have the 888, right? So if I click on add, you see here, you have the distance between the lines. So here I want to add a new dimension. So this is the difference between add and show, okay? So let's say I want to change one of this base, which is 8 meter, to, for example, 3 meters, okay? So let's say 3 meters, okay? And then, so I will just come to, for example, this bay, okay? So start from here and then to here. And you see right now, let me, okay, so here, sorry, I forgot to enter, okay? Because it still is reading actually not the previous one. So right now I have 3, okay? And then enter. So I can select this node. I will say that, from this node to this node is only 3 meters. Okay, so you can adjust it. So then now we know that, the add, it means that, add a new dimension. Okay, but show, which means, show the distance. Okay, let me just go back to 8. Okay, and let me also close this dimension as well. I don't need it anymore. Okay, so now we have this frames. Again, I will go back to planes and I don't need the reference lines again anymore. Okay, so I will hide this Y and Z reference lines as well. So now let's go to add the tie beams and purlins and maybe braces. Okay, so again, for adding the tie beams, I will go to the bar from here and start from here. Okay, go ahead to the end. Okay, so the software automatically detect the internal nodes. Automatically, they will be connected. Again, something different from StatPro. Okay, so in StatPro, if you start from here to here, so this node won't be connected. Okay, but here the software, catch the internal nodes automatically. Okay, so then that's why you can see the color of this beam again, as a bold black color. Okay, but again, we need actually to think about it as a designer, whether we need to keep this one as a single member, or we need to let's say divide the member at certain locations, or maybe at each base. Okay, so it depends on the connection type that you are looking for. For example, if we look at this column, and here we know that this beam is a continuous beam, okay, without any breaking or division. So that's why if I go to, for example, just let's say this is the column, and if I have this beam as a continuous beam, so it will be like this. Okay, and then so if you have such condition like this, maybe here you want to create the for example end plate, and then you want to create the hunch here, and then you want to bolt it something like this. Okay, but the beam should be considered as continuous beam. So then you have the options. Okay, so that's why we call it, you have the physical modeling approach in CYPE 3D. Okay, but maybe you want to come up with the connection like this. Maybe here you want to provide the fin plate or maybe cleat, okay, as a shear connection, something like this. Okay, and then here you have the options. Let's say here you have the fin plate like this, right? And then so you need to break the beam like this. So that's why this is not the case. Okay, so you need to break the beam using the elements, this option. And another thing is that the distance for each bay is 8 meter. So let's say in terms of the availability of the sections in the market, or let's say for manufacturers, so we have them with the maximum length of 12 meters. Okay, so maybe for any reason, for example, you want to divide the member somewhere here, as a 12 meter, let's say from here to here, 12 meters. And then here you want to come with the, let's say, splice. Okay, so here you have the, for example, I-beam, something like this. And then so you want to provide the splice like this. Okay, so you want to provide the splice. And maybe, the phalange splice as well. So sorry, I'm just, trying to, something like this. Okay, so then you can, just break it here. So you have all these options using the elements. Okay, this option, elements. So let's do it in the first step. So I want to just break all the members at one shot. Okay, so I will go to element. And so once you are using element, so always you need to select, if you want to break, the entire member, so you can select two continuous nodes. Okay, for example, I can select this node, just click on this node, and then again this node. Okay, you see this node and this node. The software says that, do you wish to create an element? I will say yes. You see the entire member color turn back to the normal color. Okay, so again, it means that, quickly you can understand that this member is a single member or broken member. Okay, so I will go to copy this member and put it, somewhere here. So the copy option again is here. You see, still I'm under geometry. So this is the workflow. Okay, so I can complete my geometry, and then later I can go to the properties to assign, for example, releases, or maybe, the support, and so on and so forth. Okay, but the beauty is here. So you have a very simple workflow. Okay, so still I'm under geometry. So I will go to the copy option here, copy, and
Sorry,
here,
Dr. Khalid.
yeah, please.
Uh, does this mean when you already break the element, they'll be considered as simply supported?
You mean this
Yes,
members, you mean?
yes.
No. Still you have the let's say, how can I say that? You have the rigid members. Okay, so the entire members actually, or the entire moment, will be transferred from the beam to the column, column to the beams. Okay, but if you want to make it as simply supported, so you need to release it. Okay, so that's why
Okay,
I'm saying, so, for those things, so you will go to the properties.
okay, understood.
Okay, so in this step or stage, we are completing the geometry of the structure. Okay, so for copy, so I will go to copy option, just click on that. And if you look at this small icon that you have here, this one, okay, just click on this, and you see you have different views. Okay, if you look at the global coordinate system, so quickly you can understand which view is the best view to select the members. For example, I want to select, this tie beams. Okay, that's why the best view is YZ view. Okay, so I will go to the YZ view, this view, and I can take advantage of the selection mode that I have, which is just like AutoCAD. I can come from left to right. Okay, and all the let's say, the members that let's say, just fall inside the selection mode will be selected. Okay, so just like this. And if I come to, for example, this 3D view, this one, you see all the members are selected. But again, if you look at the instruction, the software says that select a group of elements. Okay, already I select them. So what should I do in the next step? Again, I need to confirm it, right? By right click. Okay, so as soon as I do right click, so again here you see the next step, insert the first point. Okay, so I will start, or let's say take it from here and then put it here. That's it. So now let's go to position the purlins, or define the purlin positions. I can again, just like before, I could go to node and then new. Okay, you see here, if I start from here, again, you don't need to waste your time, just to play with this and come with the exact distance. Okay, just click on that, assume that I have 1.2, enter. okay, I can again, this node, the new node will be reference, okay, and then I will go there 1.2, and again here I have it. So I can go there 1.2, and then so I have it. But again, this is not the way, yeah, it is really time consuming. So we are looking for a faster way. Again, I will go for Control Z, Control Z, Control Z. Okay, so let's go to generate again, and this time nodes and bars. Okay, nodes and bars. Click on that. Again, look at the instruction. It says that select an element. So for this option, nodes and bars, so we want to say that, okay, how many segments I need based on the purlin positions. Okay, how many segments of the rafter. So that's why I know that, the rafter is a start from here and to this node, okay? You see by default is one segment. Okay, but I selected, right? So the software says that select an element. So right now I selected the rafter from this node to this node. And then the software shows me this is one segment. Okay, what should I do in the next step again? I need to confirm my selection, right? Again, right click. Again, as soon as you did right click, so here you have the number of segments or divisions. So let's say here, go for 5 segments, okay? Again, representative as Perlin locations. Accept. You see here, quickly, you have it. Okay, I can do the same thing, for every of these rafters, but the question is that, do I need to do that? No, really. Okay, or you can, even go there, and you can, the same thing, okay? But I'm not going to do that, so I want to show you, again, another feature, okay? So for this one, again, I will go to the bar, or even I can go to the copy option. Let's go to the faster, let's say modeling option. Okay, I can take a copy of this. And again, so I will go to YZ view. I will select, this members, tie beams. Let's take advantage of this beams. I can go back to 3D view, this option. And the software still is waiting for me to confirm my selection. Do right click. And then so I can, select the first point. And then so I can put it here, here, and here. Okay, so I can put actually now the purlins. And again, as you can see here, all the rafters turn their color to bold black color. Okay, so it means that again, if you go to the section, click on the section, and if you click on the rafter, you see here, the rafter is a single rafter. Again, it's not like a StatPro divided to many segments. This is the thing that happening in reality, right? Okay. So now the next step, so we can add the braces. Okay, so again, I will go back to the bar. Okay, just click on the bar option. I don't know if you noticed, you see, once I click the bar option and I will start, for example, from this node, I can go here and you see the command is active. Okay, again, since you are familiar with the StatPro, I'm trying actually now to give you kind of feeling, okay, and you can understand the way of modeling in CYPE 3D. In StatPro, again, so once I click here, so the command will be released, and again, you need to click here and you need to come here. Again, the command release, you need to click here and then go there. So this is the way that we are doing in StatPro, right? But here, so continuously you can go ahead, okay? You see here, continuously we can go ahead. And then do right click to release the command. So we have two options, right click to release the command, escape to exit the command. Okay, so right now, you see I created like this, okay? But the command you see here still is active. I can start from here, okay? And then go there. So let's say here, and again here, and here. Okay, again, now I can either, just release the command or exit the command, okay, by right click or escape respectively. So I will just click on escape just to show you the, let's say, the braces. Okay, so another cool feature that we have here is the tags. Okay, so always I encourage CYPE users to use tags. So what is tag? Tag is like a layer manager in in AutoCAD. Okay, it's something different from group. Okay, so here we have the group and then we have tags. Okay, so again, tags is like layer manager in AutoCAD, just to let's say expedite your modeling speed. Sometimes you need to, let's say, isolate some part of the structure. Maybe you want to hide or show some part of the structure. Maybe you want to see the 3D view of a portion of the structure using the layer manager. Okay, you can do the same thing here inside 3D. Okay, so as you can see, by default we have the by default tab, and the color is let's say black. If I just click on the color, and if I change this one to, for example, orange color, you see everything just turn to orange color. But let's go back to black color, and let's see what element we have here. Okay, so I have the columns, I have the tie beams, I have the purlins, and rafter and braces. Okay, so 1, 2, 3, 4, 5 different members. Okay, so that's why here I will come to add and click on plus button 5 times. Okay, 1, 2, 3, 4, 5, and I will show you how these tags can help you to expedite your modeling significantly. Okay, so for the first one, I will rename it to, for example, column. The second one, so I will just rename it to rafter. For the next one, I will rename it to tie beam, let's say. Okay, for the next one, I will say purlin. And for the last one, I will say brace. So now quickly I can come to the colors. Okay, for each of them, quickly, just select some colors. Doesn't matter. Okay, so this is the color that I selected. You can select any color. And now we need to assign these tags, or let's say layers, to correct members. Okay, so here I will go to this option. You see here, assign elements to tag. So just click on this option. And you see right now you have the bars. Okay, so if you have the shell elements, so the shell element will be appeared here. If you have the panel load, will be appeared here. But right now only we have the bars. Okay, so that's why the bars is here. So let's start with the columns. So again, so take advantage of this view options. I can go either to X Z view to quickly select the column, or I can go to this view. Okay, up to you. So let me just select the columns. Okay, so I can select, let's say something like this quickly. Come back to 3D view. I want to let's say unselect or deselect the braces. So anytime if, let's say, mistakenly you select any member and you want to deselect or unselect the member, you can press shift again, just like AutoCAD. You see, this is um, the easy way that I believe every engineers actually know how to work with the AutoCAD, right? So that's why you need to press shift and then select the members that you want to deselect them. Okay, like this. So now the columns are selected. Remember, we are assigning the tags to the columns. Okay, so once you select the columns, again, you need to confirm your selection. Right click. Okay, so first of all, we need to replace with the default by default layer. Uncheck the by default layer and then select the column layer and then accept. You see here right now, it's turned to green color. Now I can hide it. You see here, I can quickly hide it. Okay, I can go to the rafter. For the rafter, I will go to this view, YZ view. I will select this guy, or maybe I can select shift. Okay, so I can select something like this. Okay, because I don't want to select the anyway, so it already selected. Doesn't matter. Okay, so let's go ahead. So I will also select this guy. And again, so I can press shift, or I can come to, let's say, XZ view. I can press shift and then select all of them. So now all the rafters are selected, right? And again, do right click, already replaced is selected, uncheck by default, and then check the rafter. Okay, so I have it. And again, so you can hide it. So the next one is the tie beam. Okay, so I can select, again, go to this view. I know this is the tie beam. So from here and here. Okay, and again, do right click, uncheck by default, tie beam, and then accept, and again hide. Okay, so now I can go to the purlin. Again, I will go to this view. I will select this one, this one, this one, and this one. Okay, so like this, and again do right click, uncheck by default, check purlin, accept, and again hide. And the last one is the braces. Select all the braces, right click, uncheck by default, select brace. Okay, so now I can bring back all other, let's say, members which are assigned to corresponding tags. So now, since I have the tags, from now on, the modeling is super easy. And working with this model is super easy to me, to assign the properties or specifications, okay, or maybe modify, any member. For example, here, I want to group the member, okay? So here we have the grouping of the members, okay? So that's why you see this empty space that we have here at the top of this 3D cube, the eyes and the lux. Okay, so you have some empty space, right? If you click on, for example, on above the eyes, you have the empty space. Just click there. You see, you have the arrange, select all, unselect all, invert selection. So let's say unselect all. So which means, I can hide all of them at one shot. And then, so I want to only bring back the columns. Okay. And now I can go to group option, select all the columns. And again, so you need to confirm your selection. I'm repeating, just to keep it in your mind. Okay, so you need to confirm your selection, right click. The software says that, do you wish to group the selected elements? Yes. Okay, so right now you see, if I select any of these columns, so they will be highlighted with the blue color. Okay, so now I did it with the columns. I will go to another one, the rafter. You see how easy is that? Okay, I will select all the rafters. Already the group option is activated. Okay, so right click, yes. Okay, hide it, go to tie beam. Select all the tie beams, right click, yes. Okay, hide. Go to purlins, select, right click, yes. And again hide. And the last one, brace, select all, do right click, yes. Okay, again, so bring back everything. So you see right now, so if I go to any of these members, you see they are belonging to corresponding group. Okay. So now let's go to create, or let's say copy this braces. Okay, so I want to copy the braces, to the end bay here. Okay, so now I know that this is very easy, right? So, and especially, you know, once I have the grouping and tag. So here I have the copy option. Okay, just click on copy. And from here again, so quickly I can go to the empty space above the I and then unselect all. I activate the brace. Okay, or here you have the lock option. Let me show you this. Okay, select all. You see here this lock options. So which means if you lock this members, they 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 won't be selectable or snappable. Okay, so for example here I will say that here, let's say unselect all. You see here I locked all the things, and then here the copy option is active right now, right? But you see nothing can be selected because I locked them. Okay, but I want to unlock the brace. You see here only I can select the brace. Okay, you see here the brace is selected. And then, so I need to confirm my selection again. How? Right click. Okay, so I can start from here and then, but here is not selectable, you see, because the columns, nothing is selectable. I can, you know, just activate this and then, so I can put it there. That's it. So this is the beauty of this tag option. Hopefully now you understand how you can expedite your modeling using tag option. Any questions so far?
No,
Okay. Is it easy?
so far still having mm, yeah.
Yeah, okay, but again, so just I want to get the double confirmation. Are you practicing with me or just you're watching?
I'm practicing also.
Practicing, right?
Yeah.
Okay, I'm not going fast.
No.
Okay, good. Thank you. Okay, so now let's assume that you know our geometry is completed. So now we can go to let's say properties. By the way, before going to the properties, so here you have different options. But again, I remember that I forgot to assign the proper sections to members, right? So that's why let's assign the sections. Okay, so let's start with the columns. Um, for the section assignment, I will go to the section, just click on this section option. Okay, and here, since I group the members, you see, once I'm coming, you know, to select any of these columns, all other columns, you know, will be selected. Okay, so just click one of this column. You see all the columns have been selected. And then again, confirm your selection by right click. Okay, so now here we have the section library. And as you can see here, you have the rule the steel section. So with different, let's say, you know, section type, you have the built up section. If you click on that, and then here you have different section types. You have the cold form, different section type. You have the timber, let's say aluminum, the special aluminum, and then concrete. Okay, and if you have any, let's say, you know, section properties by yourself, so you can, you know, just key in here. And if you have the, let's say, concrete columns, if you want to design the concrete columns and concrete beams, okay, so you can come to concrete column and concrete beams. But under generic also you have the concrete. Okay, under generic, if you use the concrete material, so they won't be designed. You can get the analysis forces, but they won't be designed. So if you want to design the concrete members or concrete columns, so better to use the columns and beams. Okay, let me go back to generic and then rule the steel sections. And here I have the I-beam section. And from here, so I can, you know, just click on this drop down menu, come down, and I want to use the UC sections. Okay, and then so from here, let me use 305 by 97. Okay, and then accept. So here at the bottom, you have the accept button. If you want to see in the 3D view, so right now we know how to hide or show the tags and then lock the members using the lock tags. And then here we have the cubes or let's say 3D view. Okay, so we have two types of view inside 3D. We have the 3D view like this. Okay, you see here. And also, if you go back to the project, okay, so here you have the render view, okay, complete structure or active window or element selection. For example, if I go to complete structure, okay, so this is the real render view, okay. But if I come back under geometry and under tags, okay, so here I have the normal or conventional 3D view, okay, like this. Okay, I assign the members, or section to the column members. Now I will go to section again here. So this time I will select the rafters, okay? Again, since I group them, so just you need to click on one of these rafters, okay? Click on them and then do right click. So for rafters, I'm gonna use UB, okay? And let's say here I want to use the UB, let's say 406, 178, 67. Okay, so this is the section that I'm going to use, and then accept. Okay, so I can again, go there and you can see this is the rafter. Let's go to braces. Okay, so I will select braces, again, right click. So I will go to round bar, let's say for this example, and then I will use the 20 mm round bar and then accept. So again, so I can sorry, I wrongly select the tie beams. Okay, so I will select the braces. Let me see, braces, yeah, here. Okay, so here you have the round bar. And then so for tie beams, I will select the tie beams, do right click. Again, I will use the UV, but let's use a small section. Let's say 203, 103, 23. Accept. And lastly, I have the purlins, so I can select on the purlins, right click, go to the cold form, and from here, let me use, for example, this C shape. Okay, just click on this. So anywhere under section library, if you are getting, this kind of warning, the selected reference does not exist. Okay, then accept this and come to this small icon. Okay, just click on that. And then, so here you have this import option. Okay, so if I click on this import of predefined section series, so I can select, for example, this one, or maybe, usually I use the American sections, okay, this one, and then accept. I have the C section library and then accept. So right now here, I have the C sections. Okay, so let's say here I'm going to use the 100 by 50 by 20 by 2. Okay, so if you click on this info tab, okay, so here you will see what does it mean. Okay, so we have the 100 by 50 by 20, which is actually now this leg, and the 2 mm is the thickness. Okay, so I'm going to accept this, and also I can activate the purlins as well as a 3D view. Okay, so I'm done with this, but I want also, to offset or position the purlin exactly at the top of the rafter. Okay, so let's also talk about this. So here I have the position. Okay, so if I click on position, let me bring back everything, to wireframe view. And then, so from here, I'm going to deactivate the brace, tie beam, and columns. Okay, so I need only the purlins and rafters. Okay, so here, or maybe for now, I can also, deactivate the purlins. Okay, so just I select the rafters, select all the rafters. Okay, by going to position. Okay, and then right click. So here, again, to let you know, in StatPro, always we need to measure the depth of the section. and then key in the value manually, let's say, according to global or local coordinate system for a start node and end node. Okay, so you have the options again here. Okay, displacement in the global axis, in the local axis. But we have actually now a more advanced option. We call it insertion point. Okay, so here you have actually now the always I call it actually now top left, and then here we have the top mid or top middle, and then top left. Okay, so I have the mid left, mid center, and then mid right, bottom left, bottom mid or bottom center, and then bottom right. Okay, so as you can see, by default, the local coordinate system is exactly at the center line of each member. So that's why if we want to shift down the rafter, so we need to move the local coordinate system to somewhere here. Okay, so that's why simply you can click on this insertion point, which is top center. Okay, just click on this and then accept. Okay, so in the second step, so I will activate the purlins. Okay, right click. For purlin, so we need to shift it up, right? So that's why I will bring the local coordinate system to here. Okay, like this, and then accept. That's it. Okay, so I can go back and let's say, activate the or show the rafter and purlins in 3D view. So you see here, quickly you can position the purlins at the top. And even if you want to adjust this, you see here, you have actually now this kind of adjustment. We can calculate the angle, right? So let's say here, if you remember, so here we have the, let me just, from here to here, we have the 6 meter, and from here to here, we have 1.2 meter. Okay, so simply I can calculate the angle, which is inward tangent 1.2 over 6 meter. Okay, so can you somebody just calculate this, please? If you have the calculator. Anybody is calculating it? Let's see if I go to scientific. Okay, let me just calculate it from my side because I don't have my calculator. Okay, so it's 11.3, okay? So I will select the purlins, just select all the purlins. You see the positions is selected, okay? Right click. And then so here I will come to this option. You see this is again like StatPro, we have the beta angle, right? So you can rotate the members, columns, purlins, beams, rafters, whatever you want, okay? Let's say, by 90 degree or 180 degree or maybe minus 90 degree, or you can go and then here you can apply any angle. Let's say 11.3, okay? And then so enter. So right now here I have this purlins like this, okay? If I activate the rafter and then if I rotate my model, you see here perfectly you can position the purlins. Okay, so the geometry is completed, but always if you want to change the material or maybe, reverse the x-axis or move the ends, okay, any member, or if you go to the information of any of this member, okay, so you have the options, but this is not that important. I mean, it's just like any other solutions. Okay, and then so we can go to the properties to assign the releases, support, or maybe, the buckling factor, lateral buckling, lateral torsional buckling. Okay, so we have under properties. Do you have any question before going to properties?
Oh, no.
Okay, if there is no question, let's go for 15 minutes break. So right now is 4:50, let's say. So we will come back at 5:05, okay? Sorry, 3:45, sorry.
Okay.
Is it okay?
Yeah, so it's fine with me.
Yeah, okay. So we will continue at let's say 4:05, okay?
Okay.
Okay. So I will just pause the recording.
Question.
Yes, please.
For the properties, I can't seem to find square hollow sections or any hollow section.
Oh, okay. So which means under geometry, right? Under
Sections,
geometry,
yeah, geometry.
yeah, under geometry section, okay. And then so you want to use the hollow section, okay. So just for example here, I will click on this column, okay, and then right click. Okay, so the SHS, RHS, and CHS you can find under here. Okay, and then so use these three options. This one is the square,
Oh,
and then this one is the rectangular, and this one is the circular. Okay,
they,
so
they
for
were showing
example,
me error because I don't have like the database or
okay, so remember I said that, once you have the warning, so click on this small icon, edit the list of section or element series, this one.
yeah.
This small icon, okay, and then here, so you see import a predefined section series. Click on this, and then here,
Okay.
so you can select any of these options, okay?
Okay, understood. Okay.
You got it?
Yep, I got it.
Yeah, okay. For example, here I can select the SHS and then accept, you see here, and then accept. So now I have three different libraries, okay? So if I go to SHS and then here, so I have the SHS,
See, okay.
okay? Yeah, any other question?
No, that's all.
Okay. Okay, let's go back to properties. And now, once again, so we completed our geometry. By the way, as we said, so this is the workflow, okay? So complete your geometry, properties, and then go to assign the loads, and then you can also go to the automated connection generation, okay? And then you can run the analysis. So once you run the analysis, so if you want to design the connection, so you can come back to the, or let's say under analysis. So here you have the option to design the connections as well. Okay, so it means this is the workflow, but however, for example, right now we are under properties. Maybe you want to add, let's say, another member. You can always, go back to the geometry and use the options, and you can, just develop your model. Okay, but let's go back to the properties. So the first thing we may need to assign is the support, right? So here I want to assign the, for example, fixed support to this columns. Again, so maybe, one of the options that I need always to do, go to the proper view. For example, here I can go to YZ view. And you see here, this is the properties related to nodes, properties related to boards, properties related to shells. Okay, so right now we know that if we want to assign the support property to the node, or let's say to the structure, so they are corresponding to nodes. So that's why here we have the external fixity. Okay, and also here you have the internal fixity. Internal fixity, so it means that you can assign the rotational stiffness, okay, to any node. But let's go to internal fixity, external fixity. So just click on this, and then so I will select, all the base nodes, just like this. Okay, and then again confirm your selection by right click, and from here, so you have, if you just hover your cursor at any of these options, for example, this is the fix, in any direction. This is fix displacement, okay, but let's say free in X direction, free in Y direction, free in Z direction. And then so just you can read the explanation or definition of this supports, okay? And in any cases, if you want to assign any generic support, okay, so you can go to this one. Okay, and then here displacement, for example, it could be independent or over a straight line, or here you have the over a plane. So it means that you have the line support, you have the node support, and also you have the plane support. Okay, and for now, let me just go to fixed support, and then another thing is that, for example, again, you have the settlement, or maybe you have the uplift due to the expansion of the soil, let's say, okay, in the vertical direction, in the Z axis. You see here, you have the displacement or dx, dy, dz, and then you have the rotation or x or y or z. Okay, so if I go to vertical settlement or vertical uplift, so I can go to elastic, and from here, just by calculating the, let's say, the basic or simple equation that we have, F equals to K delta. Yeah. So K is the stiffness, F is the external force, or let's say internal force, whatever actually you can get from the model. And then you have the settlement already is a noun value. Okay. So you can calculate the K. So here you have three options. If you go for both, so it means that you are considering the, let's say, 25 mm as a uplift and settlement. Okay, so this is, let's say, your displacement or movement limitation. Or sometimes maybe, you have only, the positive, which means, positive Z direction, which means uplift. Okay, so for example, you have a clayey soil, which is actually, it could be expanded. So that's why you need to consider the uplift. Okay, you can go for positive. And then, so even, for clayey soil in the dry seasons, just like summer, for example, so they can, just go for, kind of shrinkage, right? And then, so you have the negative movement or, let's say, settlement. Okay, so you can either go for positive or negative, or it could be, clay soil, as we said, so it could be negative or positive. So you can, just go to this one. But anyway, so in this example, so I will go to use the fixed support and then accept. Okay, so here I have the fixed support again. So if you want to see it, you can go to 3D view. And again, so if you want to, because right now actually, I increase the node size. Okay, so I can, bring it back to, for example, 22. Okay, so I can see it like this. Okay, so this is for support. So now let me go back to the wireframe view. So another option that we can go through is about the releasing of the member ends. Okay, so the thing that you asked me about the simply supported, for example. And then, so it is also about the connection design. Yeah, so for example, you have the shear connection, or maybe you have the moment connection or rigid connection, or maybe you have the semi-rigid connection. Okay, so you can, just go to the release option, and you can assign a proper stiffness if you have the semi-rigid, especially if you have the semi-rigid connection. So you can assign the, a specific stiffness or rotational stiffness to end of any member. If you have the shear connection, so you can completely release the moments. If you have the rigid, so you don't need to do anything by default in every software. So you have the rigid connectivity between the members. Okay, but if you want to simplify it, okay, so here you have the pin ends. Okay, you have the pin ends. So if you click on pin, this option, and then here you have the individual or multiple selection. Okay, so usually I use actually no for multiple, but just to show you, how individual selection works. So for example, here I want to release the, let's say, this tie beam, which is this one, okay, at, this portion. So just, I need to come closer to this node, okay, anywhere here. You see, I'm not going exactly here, somewhere here, okay, and you see here, you have actually the release. If I come back here, so this is the release, but here won't be released, okay. So again, I can, just individually release this end as well, like this. But if I come to mid or middle of this member, okay, so which means that, I'm not closer to this node or I'm not closer to this node. Just I'm, at the middle of this member. Just click. You see both side of the member will be released. Okay, so this is the individual one. And if you want to unrelease again, okay, so just go there. For example, I want to unrelease these two guys. Okay, so just click again, click again. Okay, so it will unrelease the ends. And again, so if I go there, okay, so you can see it's released. Okay, but also I can go for multiple. Okay, so multiple, so which means you need to select the members. Okay, so for example, I want to select, this members. I want to release this members. Okay, because already I released this two members. Okay, so once you selected the member again, so you need to confirm your selection by right click. Okay, you see here, or maybe here I can, just increase the size. Okay, you see here you have the all releases. And similarly, for the purlins, I need to release them as well. Okay, so that's why again I will go to here and select all, activate the purlins, select all the purlins, and here I selected the multiple selection. Okay, do right click, and you see here I release them. Okay, so this is for releasing. Let me bring it back to something smaller. And another option that purposely I left this rafter without any purlin. So I wanted to talk about the buckling and let's say lateral buckling or lateral torsional buckling. Okay, so if you go for, or let's say activating the local axis coordinate, you see here, in this left side of the structure, I already modeled the purlins. So then you don't need to go for, let's say LY, LZ, just like a StatPro, okay? Because again, even for example, in a StatPro, once you have the purlins, still you need to go to select the rafters, okay, and say that, okay, so the LY is this and UNL or unsupported length is this. Because again, in a StatPro, the software doesn't understand the real length of the member. Everything is based on the node to node distance, okay? That's why we call it analytical modeling approach. But here, since I have the member as, let's say, highlighted or bold color, so it means that, quickly I can understand that this member will be considered as one single member. So I don't need to tell the software what is the unsupported length value. Okay, but here, let's say in this portion, so I don't have the purlins, but I need to consider the effect of purlins at the top of this rafters because I didn't model them, right? So that's why I can, just select all the left purlins. For example, here again, I will go there. I activate the rafters. I will go to this location. I will select this rafters only. So just like this. Okay. And then, so if I just come closer here, look at the local coordinate system. Okay. And then, so select the rafters, confirm your selection, right click, sorry. I should select buckling. Okay, let me just select this guy. Okay, come closer, and then here. Okay, and here also you have the, let's say, the local coordinate system, okay, as a schematic view. And as you can see here also, I can show you this one, the green one. Let me just change it to for better understanding. So this is the y-axis, and then you have the z-axis, especially, for StatPro users, they need to understand the z-axis and the y-axis is opposite, okay? And in every software, the x-axis is parallel to the member axis, okay? So here you can see the same thing, okay? And that's why in CYPE, once you run the analysis and you want to look at the, for example, major moment, so you need to look at the MY, okay? It's not like a StatPro to look at the MZ. So you need to look at the MY. Okay, let's come back to buckling factor or effective length factor. So assume that the purlin locations are at each 1.2 meter. Okay, so that's why you have the options, but the purlins will be located like this, right? In this direction. So that's why they are actually now parallel to XY plane. They are parallel to XY plane. Okay, look at here also, XY plane. So the purlins are here like this. So that's why you need to select the XY plane. Okay, so this is the way to assign the correct buckling factor or effective link factor inside 3D. Okay, in StatPro or maybe in ETABS or SAP 2000. So usually we are working on a local coordinate system, but here we work on the plane system. Okay, so once the raft purlins are in this direction, horizontally, distributed at the top of the rafters, so it means that they are parallel to XY plane. So that's why you need to come to XY plane. So that's why here you have the XY plane. Okay, so for the XZ plane, so just leave it as it is. It means that the effective length equals to real length of the member. Is that clear?
So for the exact plane, we'll be dealing with column, right? So let's say your column has high beam, you'll
Exactly,
be dealing with
exactly.
exact.
Exactly.
Okay.
So once you have the column, so it means that you have the effective length, let's say around the major axis, which is y. Okay, but here inside, so which means it is parallel to xz axis, xz plane, exactly.
If
Okay,
I
so then
define
you
my
have the
tie
column.
beam, if I define my tie beam along the columns, do I still need to assign this buckling length?
If you have the tie beam, let me understand your question. If you have the tie beam along the what?
The columns.
Along the column. I don't understand your question. So let's say,
So
for
from column
example,
to column, that's the tie beam from column to column.
oh, okay. So which means here you have the tie beam,
Yes,
something like
yes.
this. Okay. And then, so you said for this one, okay, for this one, if you have, let's say, if you have some other columns here, then yes. So you need to come to XZ buckling. Okay. If you have something, let's say, like this, maybe you have actually, some kind of member or rafter like this. So then if the member or tie beam is still as a one single beam, yeah, so you need to consider the XY
Okay,
plane. Okay.
understood.
Yeah, based on the local coordinate system that you have, so you will understand the planes. Okay, XY plane and XZ plane, and yeah, you can go ahead like that.
Okay,
Okay, so now we said that here, so the purlins are parallel to XY direction, so that's why we will come to XY plane. And then here by default is 1. So again, it means that the effective length is equals to real length of the member. Okay, but here you have two options. So either you can consider the buckling coefficient, or the simplest one is effective length. Okay, so here you can say that, for example, at 1.2 meter. Okay, that's it. So you don't need to do anything else. And then so you can assign actually, no, I will accept. Okay, and then so here, let me just clear everything. And then if I just bring up the display text on the elements, okay, so here you can see that, in the XY plane, so I have the effective length factor as 1.2 meter. Okay, but in the XZ direction, so I have nothing, which means, the entire length of the member is equals as the effective length. Okay, so this is about the let's say, the buckling. And so here also you have the lateral buckling, lateral torsional buckling. Um, let's say oftenly I'm being asked about the um, the knee bracing. Okay, assume that, for example, here, let me just activate this one. Okay, so they say that, for example, this is our purlins. This is our purlins, and then rafter. Okay, and then they say that we have the knee bracing. Okay, something like this. So from here, something like this, and then again here you have the knee bracing, right? So it is connected actually now to bottom phalange of the rafter, right? So that's why they said that how we can consider, this situation. So in Type 3D, simply you can consider this situation by going to lateral buckling option. Okay, if I click on lateral buckling option, and then let's say, if I select this rafter, okay, you see here, you can go to, let's say, bottom phalange, and you can say that, okay, so again, assume that, for example, you have the 1.2 meter, the location or spacing between the purlins. Okay, you can go for here, separation between bracing, and then so here you can say 1.2 meter. Okay, so it means that, for the bottom phalange of this rafter at each 1.2 meter, so you have the lateral torsional buckling effect. Okay, so which means, this restraint braces. Okay, so this is another cool feature that you have in Swipe 3D. And StatPro is, again, you need to go through some workarounds, to consider this kind of situation. Okay, is that clear?
Yes.
Okay, so I don't think that here we need any other specifications. Okay, so we release the members, let's say, tie beams and also the purlins. And then so we assign the external fixity. We talked about the lateral buckling and also, let's say, buckling or effective length. But here also you have other options. Here you have the pairs, especially, once you have the buckling issue, you can use the pairs. It is like let's say bracing, okay, but the customized solution. And then so if you want to go for specify the limit deflection, and also you can say that, okay, so this is the member 1, 2, 3, 4, 5. So I want to create as one group of the members, and the entire displacement of this member should not be, for example, more than 20 mm, or let's say, a span over 200 mm. Okay, so that's why here you can, do this kind of things. For example, limit deflection, if I click on that, and then here I have this purlin, and then if you just, do right click, and then so you have the absolute maximum deflection in XY. Again, based on the planes that you have. Okay, if the deflection is parallel to XZ direction, which means, the vertical deflection. Again, look at this one. Okay, and if you have the horizontal displacement, so which means in XY plane. Okay, so that's why, again, depends on your situation. So you can, use these options, or you can come here, and then so based on the code, you can say L over 250 or 300 or 400, or maybe, any other let's say requirement or specification you have. Okay, in XY and XZ. Okay, and then here you have the relative active. So the difference between active and maximum. So this is the long term, this is the short term. Okay, this is about this. And then also already, we talked about the fire resistance, but also you can, I mean, if you have free time, you can play with this, and any question, just let me know. And also you have the model analysis. This is for doing, kind of checking the natural frequency or natural period of the structure. Okay. In some cases, maybe you want to go for vibration analysis, considering the external forces. Okay. This is kind of, again, advanced training. So usually we don't support in, let's say, free of charge training. So free of charge training is for you to familiarize you with the software, the interface of the software. Okay. And let's say, the day-to-day features that you need to use them. Okay, so let's go to the load. And then, so here again, as you see, so you can apply the load to the nodes, bars, shells. Okay, but here you have two additional types of loads. The first one, we call it panels load. The second one is surface loads. Okay, so what is the meaning of panel loads and surface load? Basically, they are same in nature. Okay, but if you have the wind load, usually, is recommended to use the surface load. However, you can use the panel load. In this example, I use the panel load. And another reason, actually, to have the surface load, once you are integrating the portal frame generator with CYPE 3D, so the automated wind load generated from portal frame generator will come or transfer to CYPE 3D using the surface loads. Maybe later I can show you to understand it better. Okay, so once I want to integrate the portal frame generator with CYPE 3D. But for now, let me quickly show you for nodes. Okay, so for example, here I can go to the nodes and then click new and assume that here, let me again increase the size of the nodes. Okay, so for example, I want to apply to nodal load to this guys. Okay, and then here, so you can apply as any load that you have. By the way, remember, okay, one of the question or concern that you have, it was about the self weight. Okay, so if you remember, we manually create the self weight. Let me explain this and then I will come back to the nodal load. Here you have the options. Okay, for bars you have the self weight, and for shells also here you have the self weight. If you don't want to include the automated self weight calculation to be done by the software, so you can click on this option and then you can deactivate it. Okay, so then apply the self weight with any factor that you wish to the members. You got it, Gao?
Yeah. I saw the option. Yep.
Yes. Okay, so here you need to deactivate it. Okay,
Okay,
otherwise,
understood.
yeah, you see here, if I go to visible load case, because right now the only thing that I have is the self weight, automated self weight calculated, right? If I click on visible load case, you see here I have the self weight, okay, and then accept. You see here the software calculate the self weight of every element automatically. But if I go to self weight and then so I want to deactivate the self weight for the braces, for example, okay, and then so here I can just go to braces. Okay, let's say select all the braces, and then you see here, if I
Sorry. Can I adjust?
generate
Oh, there's a
everything,
scale there. Okay.
yeah, it's very
Yes.
nice option actually, so you can always just deactivate or activate the save it to any member.
Oh, you
Okay,
can
so
activate and deactivate for each member.
yeah, that's why here I deactivated only
Oh,
for braces.
okay.
You see here for the braces I don't have any self weight because I deactivated. Okay, so if I go back to activate, okay, so then here I will select everything. Okay, and you see here right now you have it for braces as well. Okay, so now let me go to nodes. Okay, and then I will select, for example, these two nodes. And here the value, I'm not caring about it. Okay, so just to show you, so assume that we have the live load or maybe as a wind load in y direction. Okay, so if you look at the global coordinate system, let's say we want to apply the wind load as a nodal load to these two nodes. Okay, and then here you can see this is the direction of the load. That's why here I'm not putting, let's say, negative or positive. Okay, so here This is the direction of the load, let's say in the positive X, positive Y, positive Z, and then negative X, negative Y, negative Z. And if you click on this, so you can apply in any direction that you want. Okay, so let's say in this direction, I want to apply to positive Y. Okay, so that's why I will go to positive Y. And that's why you don't need to put negative value. Okay, and then accept. Okay, so if I go to visible load case again, if I go to wind Y, accept, okay, you see here you have the load. If you want to increase the scale of the load, so here you have the scales. Okay, if you click on that, so you have two different methods: proportional to fixed value or proportional to the value of the load. Let's say here, for example, if I increase this one to 4, something like this. Okay, so here I have the 9.81. Let me edit one of these loads. If I go to edit, the loads are selectable. Okay, so let me just select this load, do right click. Okay, I will decrease this one to 4. Okay, but you see, since I'm using the proportional to a fixed value, so this is 4, this is 9.81, but both of them are shown with the same, let's say, same size. Okay, if I go to scales, and then this time I will change this one to something like this. Okay, and then from here, so let me just again change all of them to 4. Okay, and then accept. You see right now, so this is the proportional to the load value. Okay, definitely 9.81 is bigger than 4. Okay, so in this way you can also let's say visually you can see the magnitude of the loads as well. Okay, so let me just go to boards. Okay, so under boards, so if I click on new again, so assume that I want to apply the load, to this rafter. So once you select the rafter, let's say for example dead load, I will select on this rafter, and then so here you have the concentrated dead load to the member, fully UDL, partial UDL, triangular UDL, trapezoidal UDL, concentrated moment, constant temperature, and also variable temperature. Okay, so let's
Sorry,
say, for example,
Dr. Khalid, how do I assign
yes,
the self-weight again?
come again, please.
How do I assign my own self-weight?
Your own, yeah, okay. So let's say here I will change to self-weight, right? And then
Yep.
here, so I will say, for example, you want to assign it as 1.2, right? Because
Um,
this is a kind of, let's say, member load.
can I not do the factor of the member property?
Member property,
So let's say I
um,
have different member. Let's say I have one hollow section and one universe UB. So I want to assign like a factor of 1.05 for each member.
to material, you said, right?
Yeah, yeah, yeah.
Okay, for the material, okay, so you can do like this. Okay, so let's say for example here, okay, you can go back to the project, general data, and then limit state. Okay, you see here you have the characteristic loads. Okay, configure combinations for each limit state. And then here we have the rule the steel. So I can go to project situation, enter by the user, and then from here, so I can create one for myself. Okay, so let's say for example, user define load combination or whatever it is. Okay, and then so I will add one of this, let's say,
Oh,
combinations. Okay, so here you can actually apply this one as let's say 1.2, let's say favorable or unfavorable. This is
I
actually
see.
related
Okay.
to related to material.
Okay. Understood. Understood.
Yeah, so did it address your question?
Yeah, 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 yeah.
Okay, good. Okay, so this is related to material. That's why here you have the ruled steel or concrete or whatever you have. Okay, so let me go back to the load. And then again, so I will go to the bar and then new. So let's say here, assume that I'm applying, as a dead load or self-weight or whatever. Okay, so but if you want to assign as self-weight, so please deactivate it under this option, because as we said, so the self-weight automatically will be calculated, okay, by the software. So then you have the double sulfate. Okay, so here I will select this one and then assume that here, so I want to apply the fully UDL. Again, you have the global access, you have the local access. I believe everyone knows about the difference between local and global access. Okay, so and then here by default, the gravity load or negative Z value is selected. Okay, and then if I apply to this, so here you see that you have actually now the fully UDL. But I want to show you an easier way. Let's say, the panel loads. Okay, so I can assign the pressure load of the roof, or maybe you have the solar panel, or maybe you have the, the area load due to M&E, maybe, the services. Okay, and then so using this option, the software automatically decompose the pressure load or area load to member load automatically. Okay, so let me just show you. So here you can go to the panels, and then so I can start, for example, from this node, and then so I can come to this node, and then so just right away to this node, and then this node. And before closing this, I can do right click. Okay, and then here it says that select the distribution direction of the loads. Let me accept this. So since here I don't have the purlins, so then I need to load the rafters, right? So here I need to load the rafters. So that's why, the distribution direction of the load is in this direction to load the rafter, correct? So that's why you need to select either this line or this line, doesn't matter, one of them. Okay, so for example, if I select this guy and then right click, I can close this for now. Okay, so let me just create. Okay, so here you see I have actually now the panels, and this is the distribution direction of the load. And then so let's go to this portion. Okay, I will select from this node, this node, this node, this node, and again before closing, right click. But this time here I have the purlins and I need to load the purlins. The distribution direction will be like this. Okay, and then the purlins will be loaded. Okay, so here I will select either this line or this line. Okay, let me select this line and then right click and then close. You see here, so this is the distribution direction of the load. Okay, so now I want to apply the wind load as well. Okay, so I will create another panel here, and again before closing, right click. So this time I want to apply the wind load along the height of the structure, so which means in this direction, which means the columns. Okay, so then I will select this guy to load the columns. Okay, like this. And similarly here, so I will select this one, and also here, let's say in X direction, so I want to apply the wind load. Okay, so again along the height of the structure, so which means this column and this column, so I will select this guy. Okay, and then the last one here, and again here. Okay, so now I have the panels, and it's easy for me to just apply the pressure load, and the panel load automatically convert or decompose the pressure load to member load. Let's do this. Okay, so I will go to edit option. First of all, let me apply the dead load and live load. Okay, so here I will apply or let's say select these two panels exactly on the top of the roof, and then right click. Okay, so here I have the options for dead load and live load. So I will add two loads. Okay, so dead load and then live load. So let's say for dead load, just add dummy value. Okay, let's say I will say 0.5. And then for live load, assume that we have the non-accessible roof. and then so I will go 0.4. Okay, and then accept. So right now here I have it. If you want to look at the load on the member, again you can go to visible load case. Okay, you see here I have the dead load. Let me look at the dead load, and you see how the loads are applied to the rafter for this one. If you look at the distribution direction of the load, and then here if you look at the distribution of the load, and then the purlins are loaded, and then here you can see the value of the load. I applied the pressure, but the software automatically decomposes it to member load. Okay, and now let's go to apply the wind load in y direction, let's say for windward and leeward. But here I can see that the dead load and live load also assigned to this member as well. So then here you have two choices. Either, the braces or like a cable, which is you have the tension only member, or maybe you have the braces as angle, equal angle or unequal angle. And then so you want to consider the compression effect of the member as well. So which means the member is not tension only or compression only, but they will act as axial member, which is for both tension and compression. Okay, so what you need to do here to deactivate the member to get the surface loads. Okay, so here this is the option, activate or deactivate surface load assignment. If I click on assign, again here I will go to unselect all. I will select the braces. Okay, and then do right click. So right now you see here it will be shown like this. Again, if I just go back to visible load case, dead load, you see here the braces is not getting the load anymore. Okay, so let me apply the wind load in y direction. So again, I will go to edit. You see, once I have the panel, so just I will go to edit. So this one is the windward. Okay, so if
Sorry,
you
just a
look at the,
question.
yeah, please.
If I define my wind brace after I define my load, will the load still be decomposed into the wind brace?
Yes, doesn't matter. For example, here right now I have actually now the panel, right? Assume that I want to add another member. Okay, so for example, here I want to add a member from here, for example, to here, right?
Yes.
And then if I go back to the load and again visible load case, but here I have actually non-deperlin. Let me continue with this one in this location because the distribution load is different. Okay, so I will assign to this and then load visible load case, and then let me
So if I
see.
define it after, they wouldn't get decomposed? Is that how it works?
No, because this member also should get the loads as well.
Oh,
Yeah, as long as you have the panel, okay. So the member will get the load. Doesn't matter it created before creating panels or after creating the panels.
okay. So the only way to remove it from the member will be to delete the assignment to the member, right?
Yes, yes, correct.
Okay, understood.
Okay, so yeah, let me just come back here. So I was talking about yeah. So edit. Okay, so this time, so if I go to this view, you see here in the y direction, so here is the windward and here is the leeward, right? Okay, so I will go for windward side first here and then do right click. So you can assign the wind load as a uniform or vary depending on the height. Okay, like a, let's say, triangular type load. Okay, so let me go to vary depending on the height and then click on this. So I will say go to wind in positive y direction. You see the software again is smart enough to understand the position or positive direction, and then in the x direction is 0, which means no load will apply to the x direction and no load will apply to z direction. All the loads is go to y direction. That's why you have the 1, which means 100% of the load is going to y direction. Okay, and then here you have the value at the bottom level and at the top level. Okay, so let's say, for example, in the windward side, um, you already have the, for example, wind speed, right? Yes, for example, you have 30 meter per second. Okay, so you can, just convert it to pressure, and then so here you can assign it. But right now here I'm using the vary depending on the height of the structure. Let's say 0.1, and then at the top, assume that we have the wind speed as 30, 33. Okay, so usually we have it as 0.6, 0.65, something like that. Okay, and then accept. So right now I have it. So let me go to leeward side. Okay, so here click on this, and again vary depending on the height, and again wind positive. So here again I will say 0.1, but in the leeward, so we have the suction, right? So then let me assume 0.3. Okay, and then accept. So again, if I go to visible load case, so you can look at the wind positive Y, and you see here, so the software automatically again, get it or assign it to the columns. Okay, so it depends on you, how do you want to distribute the loads. So now here also in this roof, I have the windward, and this roof is the leeward side. Okay, so again, I will go to edit. So I will select this one, leeward, windward. And then, so I didn't select all together because, at the roof, even because I had the dead load and live load. So that's why I wanted to select the panel load at the roof separately. Otherwise, the dead load and live load, will be removed because you are selecting all together, and then you said that only I want to apply the wind in positive Y direction. Okay, so that's why I selected, this portion separately, and then since I had the dead load and live load at the top of this roof, so I right now selected them, and then I can add another, let's say, type of load, and this is the wind positive Y. But again, look at here, in the X direction, the software doesn't apply anything. In the Y direction, because you have the sloped roof, right? So that's why, it also calculate the angle of the roof in the, let's say, the Y direction, and also in the Z direction, because it's not purely vertical. So that's why the software again is calculating this very smartly. Okay, so again, since we are in the windward side, so I will apply as 0.65 and then accept. I will go to this portion, which is again leeward. Again, add another load, which is in the Y, 0.3. Okay, I have it. Again, if I go to visible load case, okay, you see here, you have it. And then here, the purlins are taking this loads as, let's say, uplift. Okay, but again, so this is kind of thing that you need to, let's say, calculate it based on the uplift and pressure. And you can, just come to the subtraction of the pressure and uplift, and finally you can come whether they are, or let's say whether they can be applied as a pressure or uplift. Okay, so here you have it, and then let's
So
go
if
to
you
the
want to,
X.
sorry, if you want to apply as an uplift, do you need the negative sign?
Yes, yes, if you want to apply it as a pressure, okay, just put one negative.
Okay, okay.
Yeah, because you see here, if I click on this, you see here it says a positive direction, downward vertical, downward vertical. Okay, so now let's go to the X direction. So again, here in the X direction, I can consider this one as the windward. Okay, and then so this time, just for again, demo purposes. Okay, so I will use the uniform, and then I will change it to X direction. Again, let me assume as 6.5, accept, and this is the leeward, this side. Again, add 1, wind X, 0.3. Okay, accept. If I go back to visible load case, this time I want to look at the, let's say, X direction. You see this rafter also taking a portion of the wind load, because this rafter is not purely vertical and purely horizontal. So that's why it contributes to the getting the load. Okay, so here you have it. So now we apply the load, wind load, and let's say, the member load. I showed you already, using the panel load. So quickly you can apply the pressure and leave the, so, the next stages to the software. And the panel load automatically decompose the pressure load to member load. Okay, so now let's go to the next step, which is actually now the joints. Okay, so the joints could be after analysis, but they put it actually now just like this. It means that here I can go to generate. Okay, if I click on generate, the software again is smart enough to understand the typical connections. Okay, for example, at the apex location, we have the similar geometry, the same geometry for the apex. Okay, here, for example, at the location of the tie beam connected to this column and rafter, so we have the typical connections again. Okay, if you come to the base of the internal columns, again, you have the typical base plates. So that's why the software says that, do you want to group the typical connections? I would say yes, go ahead. And then here, so 19 connections have been generated automatically. And then if I accept, I would see what kind of connection I have. Okay, so here, so I have actually now, or let's say the software is able to design this connection, design the base plate, and design the apex. As you can see here, the apex is here. But here, the software is not able to design the connections because here we have the braces coming from the wall braces and roof bracing. And then, so here you have also the tie beams, rafters, columns. So how many members? 1, 2, 3, 4, 5, 6. 6 different members are coming to a shared node. Okay, so we cannot consider it as standard type connections. So that's why you need to send the information to CYPE Connect, which is the advanced connection design software, and you can design it with, let's say, any geometry. But if you don't want, even here, if you don't want to consider the effect of this braces, to this connection, still you can go to new and you can create the connections manually. Okay, so if I click on new, I will select, for example, this rafter, this tie beam, this column, and then this tie beam again. Okay, and then right click. Okay, so here again you have it, and I can accept it for now. Okay, you see here you can even create the connections manually by yourself. Okay, so this is for connection. So now we can go to the analysis. We run the analysis, and then we will have the analysis forces or beam end forces, and then we design the connections as well under analysis. Okay, so that's why they put the joints before analysis. Okay, so here let me just go to analyze the structure. If you click on that, you see you have the design of connections. Okay, so from here you can just go there and design the connections. If you want to understand what kind of connections can be designed, so here you have the available joints modules. Okay, so for example, you can go to the welded joints. Let me click on this. You see all these welded connections are possible to be designed with Type 3D. There are too many, right? And then, so if I go back to bolted connection, okay, so here you have all the bolted connection. If you have such geometries, it means that you can finish up the connection design inside 3D itself. So you don't need to jump from the software to any other solutions. And also the hollow sections. Okay, if you have such geometry, again, you can finish up inside 3D as well. Okay, so now let me just go ahead with the connections as well. So here you have the check bars. It means that if you want to uh, check the design of the members, okay, so you need to check this option. Okay, if just you want to get the analysis forces and you don't want to design the members, uncheck this option. Okay, but right now I want to design these sections as well. And then here you have the consider the finite dimensions of the node. It means that to consider the rigid zones of the members. So you can activate this or you can deactivate this. And here you have the section design. So right now, if you remember, so we assign the specific sections to the columns, rafters, tie beams, and braces and purlins. Okay, so we don't want to change these sections. Assume that you have the existing structure, you are doing the strengthening, and so you have no choice, to increase the section size or let's say, the material properties of the section, because already is existed, right? So that's why here you can say that do not dimension sections, okay? But if you have the new structure and you want to come up with the preliminary design or primary design of the sections, so you can, just, check this option or check this option, up to you. So usually, these two options almost work in the same way, okay? And the software, just select the best sections from the section series that you are using. So let me just go to do not dimension the section. But even using the option do not dimension sections, later if you want to optimize the sections, is super easy. Just by one click you can get or you can do the optimization. Okay, so let's go ahead with the analysis. But for designing the connection, the software says that do you want to go for welded connection or bolted connection? So let's go for bolted connection. Okay, and then accept. Okay, so here it says that this is the final design report. Okay, so the connection type 4, which is 4 typical connections, N60, 63, 65, 68. Okay, so they have some kind of issue. And then here it says beam IPE80. So most probably I haven't assigned, a correct section, because IPE80 is really a small section. So that's why the software couldn't come with the solution. And then another, let's say, report that I have, there are elements which have been assigned an inadequate rotational stiffness. Is okay. And then, so the fire check option has not been activated. Yeah, I didn't assign, or let's say activate the fire resistance. Okay, so I will close this. Let me go to um, um, joints first of all. Okay, and then so if I go to edit, you see this joint that I created is already passed. So whatever joints actually now is coming with the green color, so which means already they are passed. Okay, so if I click on this connection, you see here I have the connection. And look at here, the beauty of this connection design. Remember, we released the tie beams, right? And then here the software comes with the shear connection. And then here they put the stiffener here, and then so the section already cut. Okay, and then so you can go to the drawings as well here, detailing. Okay, and you see the software gives you all the detailings as well. Some of our SERP 3D users, they said that, however, this is not a shop drawing of the connections, but they are so close to shop drawing, and they are, let's say, super happy, with the connection drawings. I believe you have the same feeling, okay? So because this is actually, no, I can say that, and to the best of my knowledge, this is the only software that comes with the 3D connection design under standard type connections. And then it will give you all the step-by-step calculation report and all the drawings, as you can see here. Okay. So let me just, and if you want to look at the step-by-step calculation report, you can go to the code check. Okay, so this option, if I click on that, and then here you see, so you will get all the step-by-step calculation report. By the way, this, let's say, automated connection design can be done under generic Eurocode and American code, and some other international code which is not being used in Malaysia, like Italian code, Brazilian code, okay, and if I'm not mistaken, Indian code, okay. But if you are using the British code, so you cannot come with the automated connection design. So you can send the information from CYPE 3D to CYPE Connect to design the connections according to British code. And here you can see you have the view the complete listing. Okay, so this option here, if you click on that, you can see the report in a single format. Okay, so for example, this is the first typical connections N46 up to 57, and then so you can see the step-by-step calculation report.
How about checking the utilization ratio of each member?
Yes, I will show you because I just went back, to discuss about the connections. Now, you see here, for example, this braces is coming here. The software is also able to design the braces as well, or let's say, braces connections. If I click on that, you see here, so here you have the connection, but you can read the information, okay? For example, here, this is IPE 80, okay? So, but if you remember, we had it actually, as round bar, right? So that's why here I can change this member. I can always go back to the geometry and let me see if I group this. Yeah, you see, for example, I didn't group this braces with this braces. Okay, so let me just unselect all and then braces. Okay, so I will select the braces. Okay, and then so I will group them. Let me see if I have the round. You see, if I hover your cursor, so at the top right, you can see R20. Okay, and again, so I can go back there, run the analysis. So design of the connections as well, accept, accept. And you see the analysis engine is quite fast. Okay, so right now we have the design report again. I can go back to the joints. Again, you can go to edit to see the joints. Okay, so here I can see the joints. So here the joints are passed. But again, here, since I have the rod, or sorry, here I have this kind of bracing like this, okay? So, and then for the columns, I have like this, okay? So this is not possible to do it in CYPE 3D itself. So that's why you can send the information to, again, CYPE Connect to design these connections as well, very well. Okay, so in terms of the utilization ratio, so you need to go back to the analysis, and then here you have the check elements, okay? So if I click on check elements in a very quick way, so I can see whether the members are failed or passed, only with the red color and green color. Let me see here, for example, the purlins are failed, but let me also see if I assign the purlins. And yeah, you see here, if I go to the purlins, so I'm using the C15020. Okay, again, if I click on check, you see once I'm hovering my cursor at top of the purlins, you see the resistance or DC ratio. Okay, so it is 497. Okay, 497. You see that? And then here you have the 738. Okay, so here you have the 738. So this is actually, the worst or critical members for the purlins. If I come down here, I have 497, but here I have 738, correct? So if I click on any of them, let's say here, and then come down, the software tells me that, okay, so you cannot use, all the sections, but you can use, for example, this one, and then the utilization ratio will be 91%. You see the super easy optimization. Okay, so let me change this to 275, 124.5, accept. Okay, and you see all the purlins already passed. So let me look at the braces. Okay, so for the braces, I have the, let's say, excessive compression axial force. Okay, so if I click on that, and again, so if I come down, the software says that, okay, so you need to use either, let's say R50, and here you have all the utilization ratio. Okay, so let me use, for example, R55. Okay, and then accept. You see, so in this way, quickly you can design the members. But let me bring it back to 20. I want to show you the utilization ratio. Okay, so again, let me run the analysis with the connections as well. Okay, so now we learned that, this check elements quickly show us the green and red color. Okay, but if you go to the forces, and then if you look at if you go to the envelope, and then go to the stresses. Okay, so here and at the bottom, you have the utilization ratio. Okay, so you can see it in this way. And again, so we have very positive feedback, especially from stat users, that they say that, or they like this more than stat pro. Why? Because in stat pro, again, especially once you have the complicated model or complex model, and a very big size structure. But again, remember, in a stat pro, once you have the nodes, the member will be divided to small members. And then once you activate the values of the members for utilization ratio, so they will usually overlapping each other. Okay, and then so you cannot see the value clearly, right? So here you have actually in this color coded way. Okay, for example, if you look at this purlins, okay, so you see that the purlins are about the 90%. Okay, if you just go to view option, okay, you see here this is the 98% of the utilization ratio. So that's why here you can see it in the almost red color, but they are not failed, because if you go to the check elements, okay, so this is here. And not only that, you see this option ULS check. If I click on that, and then if I go to any member that I have, for example, if I go to this Perlin, and then so I can look at the step-by-step calculation report according to the clauses of the code. Okay, but the thing is that here I have at the worst point and at the indicated point. Okay, if I go to at the indicated point and then click on this member, you see the software just divided or show us some certain nodes. Okay, so if I come to here, you see the DC ratio is 5.2 and then 23, 43. So if I come to here, this is 96, 92, 98. Okay, so it's exactly at the middle of the member. Okay, so this is very important and very useful, especially once you want to understand the concentrated of the stresses at what location of the member. Okay, so this is let's say very useful. Let me show you an example. If I go back to the geometry section, let me select the rafter and I want to add the hunch, okay, to the rafters. So once I select the rafters, do right click, and then here you see right now I'm using the simple section. By the way, quickly you can create the built-up sections. Okay, so for example, simple with hunch, with concrete slab, double welded in box, double welded in box with button plates, double in box generic joints, half section with lateral plates, castellated beam, hexagonal, octagonal, or circular. Okay, so let me go for simple with hunch, and then so I want to add the hunch at the location of the rafter column connection and also at the apex. Okay, so here I will say that according to meter, I have according to, let's say, the percentage of the length of the member or absolute. So let's say, for example, I will go for 1.6, okay, at the column rafter location, and at the apex, I will go for 1.4, for example, okay, and then accept. Okay, so if I go to project and then complete the structure, so let me show you how quickly I add the, let's say, hunches. Okay, so once I add the hunches, so I can run the analysis. The software automatically again, design this for me. Okay, let me just go back to the analysis, analyze, accept, accept. Okay, if I go back to the project, complete the structure. Okay, you see here. So I have the correct connection. Okay, now let me go back to the analysis. And again, if I go back to ULS check, let me also use the smaller section, or I can select from here. Let me just go back to check element. Okay, so I want to use this rafter. Let me use this one because I want to show you something. Okay, so I want to fail this member. Again, run the analysis. Okay, and then so if I go to ULS check, you see here this rafter is being failed, but I can look at the at indicated point. If I go to adverse point, okay, so I can select only the rafter. But if I click on that, you see here I have the 103, 101, and then 100, but here is not failed. Okay, so I'm getting failure exactly at this location. Okay, and then so you see here if I go to this 198, and then so there is no failure. If I go to this location, which is actually now here because I have the concentrated of the stresses, okay, click on there, and then here I have the option only show the failed check. Okay, if I click on that, so here I have the combined bending and axial resistance, and then so you can look at it, and also it gives you the force load combination. Okay, so this is very useful. Let me just go back to check element, and then so let me use the section that I was using previously. Okay, so let me rerun the analysis. So I'm going to finalize the CYPE 3D training, okay? Because yeah, I tried actually now to cover everything, the modeling analysis, okay? And then so for CYPE 3D, we can conclude that this is actually now the training, the full training. But let me continue to show you some other things. So if I go to the forces, and then I can go back to the, let's say, force diagram, and then for all the bars, assume that I want to look at the axial forces. Okay, so you see here, I have the axial forces, and then you can increase the scale. Okay, so here you have the scale. See this one? Right now is 0.1. I can go for 0.5, for example. Okay, so here you can see the axial forces of the entire members. And then, so if you want to see the values, so here you can, display the value like this. Okay, and then here you can increase or decrease the text size. But also you have another cool feature. So we have the selected bars only. Okay, I want to look at the axial forces of the columns only. So here I will select the, let me again go there. Okay, so I will select the columns only once I'm presenting, the entire structure. Okay, in this way you can, just present your results. Let me, for example, go to moment. Again, here I have the moment Y. Okay, so the major moment. But again, assume that I want to look at the major moment. Let me press shift, and then I want to look at this rafters. Okay, and then so I don't want to look at this, and I can increase the, let's say, scale. Okay, so in this way you can, just look at the results for any member you want. Okay, so for example, let me, just deactivate this, deactivate this one. Okay, so I want to look at this maybe. And if you want to look at the reactions, okay, so just click on the reactions, and then from here you have the simple load case, and then here you have all the load cases if you want to look at, for example, under wind load, and then just select any, let's say, support. Okay, and then so here you have the reaction of the structure under wind in positive y direction. But maybe you want to look at the services, or let's say, SLS, you can go to the displacement, and then here you have the unfactor combinations. You can go and then look at this. Or maybe you want to look at the factor combination, ruled and built up section steel. Okay, and then here, so you have all the factor combination. Let me just, okay, so all these combinations created by the software automatically. Okay, and then so here you have the reactions. Similarly for the forces, okay, so for the forces also you can look at the let's say for example combinations. Okay, so here you can look at the combination, and here you can look at this column moment. So yeah, this is the thing. And then so finally to create the report, you can go to the option that you have here, and then here you have the report. Okay, so click on the report. And assume that, for example, I want to look at the utilization ratio and the bill of quantity. Okay, so I can go to the structure. So here I have the quantities summary. So just click on that. And then so under results, so you can find the results. And then I want to look at the bars. And then here ULS check summarized, or maybe resistance. Okay, so I can click on this and then accept. Okay, and then here, so you have the quantity summary. Okay, length, volume, weight, material, sections, series, okay, type, and you can come down, and then here, so you have the utilization ratio or resistance. Let me just, okay, so here you have the status verified. Okay, so if you have any failure, so you will see not verified. Okay, and then if you want to look at the utilization ratio value, so here this is the utilization ratio value, and if you have any let's say failed member, so the software will show you or highlight with the red color. Okay, so quickly you can find them. And by the way, I forgot to show you, you can also, let me go back there. You can export the report as a PDF, editable Word file, text file, HTML, or RTF. Okay, so you have the options to export your report. And if you want to export your report to Excel file, okay, so you can go to the project, and then here you have the selected elements, or you can go for CSV of the selected element. If I click on that, assume that I want to select maybe a few of this members, let's say this member. Okay, and then do right click. So I can save it, for example, on my desktop, accept, and then from here, so you can just select the geometry, reactions under load case combinations or envelope, and then here you have the options as well. Okay, and then so yeah, you can just for example here I want to look at the board's envelope and then accept. Okay, so if I go to here, and then so you will get the results as well, and then so in the Excel you can edit it or whatever you want. Yeah, that's it for now. And yeah, we want you to just use the software, ask question anytime. Yeah, let's say any question, basic question, hard questions. Sorry to say that, silly questions. Okay, just ask. And I'm sure that after, let's say 20 hours, 15 to 20 hours working with the software, but asking questions, so you will love the software. You will be master in software, and yeah, you can use it for almost any project. Yeah, any question, please let me know.
No, we don't have any question from my side.
Okay, so any question from others? Yeah, we'll wait for another minute. If there is a question, I'm happy to answer the question. Otherwise, I will end up the session. I believe everyone has my WhatsApp number. Some of you already, created a group, but I believe that, everyone has access to my WhatsApp number. Yeah, anytime, any question, yeah, just let me know. WhatsApp me, and then I will come back to you.
Okay, okay.
Yeah, okay. Thank you, everyone.
Thank you.
And then, yeah, so we can arrange for, let's say, CYPE training as well. Okay, so for CYPE 3D already done. And yeah, we can go for CYPE and we can discuss the dates.
Sure, sure.
Yeah. Okay, so have a great day, everyone.
Okay, you too. Thank you.
Yeah, thank you. Thank you. Keep in touch. Ask question, please, and use the software. Thank you. Bye-bye.